Here we are having that one more example as determine state-based representation of a network shown below, right? So suppose they may ask question about then a network shown below, then you have to determine the state-based representation for the network, right? Now in that case, how do you do that one? We are having in that circuit, we are having two loops, right? Then as like that Kirchhoff current law, then we are having now one current is flowing through here in that loop, right? So that is I1, I1. Then here we are having now the current through this loop is here you have to consider now in that manner. This is I2. This is current through that process, right? Now here you see this one, this I1 is this direction, then I2 is opposite direction. So the current through the capacitance is I1 minus I2. So in that branch, the current through this one is here, this is one direction, this is opposite direction. So the current through the capacitance is here I1 minus I2. Current through the capacitance is I1 minus I2. Then in that inductor L1, the current is I1. Then in that R1, we are having the current is I1, right? This L2, the current is I2. Then R2, also the current is I2. Then we have to write that here loop equation, right? Loop equation. In that loop, we are having a voltage source. In this loop, there is no voltage source, right? So for the first loop, we are going to write the equation. So Vs, then voltage across the resistance is Ri into R1 into I1. Then the voltage across the inductor is LdI by dt. So LdI1 by dt. Then we are having the voltage across the capacitances. Here we are having current is I1 minus I2. So you have to integrate the current with respect to time. So the current through the capacitance with respect to time. So 1 by C integral I1 minus I2 into dt. So this is first loop equation. Then the second loop we are having now, there is no source. So you have to put it as a 0. And then here the current flow is I2. The voltage across the resistance R2 is R2 into I2. Then voltage across the inductor is here we are having L2 into L2 into Ti2 by dt, because only the current I2. Then in that capacitance, the same one, right? So whatever the voltage drop here, this is common for both. So whatever here, so you have tried this also sharing by both loop, right? Then there is no change. Now here you have to consider now the this is now what actually we need is voltage across the capacitance as one source, right? Vc equal to V2, right? Okay, then here in that equation substitute equation 3, so that Vc into 2 and 1, so that one as, so Vc you have to take this two part as Vc. So Vc as one variable and I is another variable. So you have to take the di by dt on the other end. So di by dt on the other end, and you have to make it as that one. And we have to write state equation, right? So I1 x1, I2 is x2, and Vc is, so we are having three variable. So I1, I2, and Vc. So now we have to consider now three equation for that one, right? So now here, how do you write that one as here? X3 dot, right? So VC is X3. Now you are putting the dot is here. So you have to differentiate that one, right? So that is, yeah, we are having the X3 is, so if you are differentiating that one, then the integral part is, now we are having integrate that x1 by dt is equal to x1, right? Then we integrate, like, differentiate that one, right? So that one is here we are having that. So this differentiation of this one as this integral is going off, right? So that is here 1 by c into x1 minus x2. So the dt is in the integral part and dt is removing, right? Differentiate that one, right? So dx x3, this is the equation. How do you get this equation is x3 is Vc. So here we are coming now, right? Then here we are having the Vs is U. Thus in the second loop there is no source. So you have to consider as 0. Then this is x3 part is here, right? So that x3 is that Vc. So Vc, here also Vc, the Vc is going to be represented here, right? Now here we are differentiating that one. We are getting now. So this is x3 dot. X3 dot is here 1 by c and x1 and x2. Now you have to take that state equation, right? X1 dot. So a di by dt is x1 dot. di1 by dt is x1 dot. di2 by dt is x2 dot. So that one di1 by dt, that is how do you do that one as here this equation, in that equation, so you have to take this part is here, right? So that one as L1 di by dt is put one side. Then here we have to put now here we are having now this is on the other end. So we are having now vs minus r1 i1, right? Then minus vc, right? So that is we are having now this LDO. Then L1 is going to come out. Di by dt is equal to Vs by L1 minus R1 by L1 and I1, then minus Vc, right? So that Vc is we are having now that x1, x2. So that one as here we have to take this one as this x1. Otherwise here you are taking this one, right? So that is here we are writing that equation in the form of r1 x1, right? So we are writing that equation here as, I'll show that, right? Now here you see this one. How do you write that equation is, put that one as red color. Okay, sure. Now how do you write the equation is here that vs is u, this one, right? Then we are having that r1, then i1 is x1, so we are putting now that r1 x1, right? Then l1, then di by dt is x1 dot, right? So di by dt is x1 dot, so that di by dt is the differentiation of that one. So x1 dot we are placing now, right? Next we are having this is vc, so we are taking this vc as x3, directly we are taking this as x3, right? So that one is here. So we'll already we are telling that one as VC. The VC is considered as X3. VC is considered as X3. Right? Then here we are putting now that equation is U equal to U, that Vs is U, R1 X1 plus L dx X1 dot plus X3, right? Then similarly for second equation 0, then R2 X2, R2 X2, right? Then we are having now L2 and X2 dot. Then here we are having X3. Then here at that output is x3 equal to cases x3 equal to 1 by c integral x1 by x2, right? So that is we are having now x3 dot is here we are having, this is the equation. So third equation. So you have to consider first equation. So in that first equation you have to take that x1 is one side, right? So that is here x1 dot L1 x1 dot equal to u minus R1 x1 minus x3, right? Then here L1 is here x1 dot, then u by L1, then minus R1 by L1 x1 minus 1 by L1 x3, right? Similarly here we are having that equation also you have to take in that form as x1 dot out right hand side, then x2 dot right hand side. Now we are getting now that equation, right? So that is here x1 dot, x2 dot, x3 dot. So x1 dot is here. So we are having now that u by L1. So that one is here, right? Then here R1 by 1, then we are having now the resistance x1, and then here we are having now L1 by L1, that x3. So that is we are having now that minus. Similarly for that x2 is here we have to put now the L2 x2 dot equal to then minus x3 minus R2 x3. Now you have to do that one x2 dot equal to 1 minus 1 by L x3 minus R2 by L L2 x3, right? So that is this equation. The x3 is here, right? Now we have to write it in the matrix form. So in that matrix form, we have to write. So the output is here, resistance across the voltage across the resistance, right? Y1 equal to I1 R1. So that is Y2 equal to Y1 equal to I1 R2, Y2 equal to I2 R2. So that I is X1, and R1, then x2, R2. So that is the form. Now you have to write in the matrix form, right? So that the x1 dot, x2 dot, x3 dot in the matrix form. So how do you write that one as x1 dot, x2 dot, x3 dot in the row x1, x2, x3, and then we are having now this is x1, x2, x3. So that x1 coefficient is this one is first term, and there is no x2 coefficient, so we are putting now the 0, and then x3 coefficient is this one, so we are putting now this one, right? Then here we are having that output term is only in that particular equation, only we are having output term. So 1 by L1 into U. Here there is no u term, so this is 0 0. And then we are having now the second equation x2 dot, so we are having now that x1 coefficient is 0 and x2 coefficient is r2 minus R2 by L2. So we are having now this one. Next, we are having now that X3 coefficient minus 1 by L R2. We are placing it here, right? Then the third equation X3 dot equal to the X1 coefficient is 1 by C and X2 coefficient is minus 1 by C. So we are placing here. There is no X3 coefficient. So you are putting now that 0. So now this is the transfer function or state-based representation, right? In that output case, you have to write that one, right? So that one is here, y1 and y2. Y1 is we are having now the x1 term only. X1 term is r1, and there is no x2 term in that equation. So that is 0. And then we have second equation y2 x2, right? So the x1 term is 0 and x2 term is r2, then x2. So this is the state-based representation in matrix form for the problem. Problem is here we are having this electrical circuits or network, electrical network or electrical circuits.